All right, so we had some questions on 33 and 35 from 7-2. So let's take a look at those. These are sample size questions, which you have a formula for. And the key, I guess, for knowing that is just this how many here. They're not saying what's the interval. They're saying how many people, how many passengers should you survey. Okay. So remind yourself of that formula. It says the sample size is equal to, and the desired margin of error goes on the bottom, and that's squared. And the sample proportion goes there, and the complement of the sample proportion also goes there. That's b hat and q hat. And then there's this z sub alpha over 2 thing, which comes from the confidence level. That's squared. Okay. So first time around, let's see, we've got 95% confidence. We want to be within 2.5 percentage points. So be careful with the formula for that. Percent, move that decimal place 2 to the left. So there's 2.5 percentage points squared. First time around, we're assuming that nothing is known about the percentage of passengers who prefer aisle seats. So that version of the formula says if we don't know anything, assume it's 0.5 and 0.5. Assume a 50-50 split. If you look in the book, they go ahead and crunch this down to 0.25 and just make it part of the formula, but that's where it comes from. And the last thing that we need in this formula is the z sub alpha over 2 squared. So just as a reminder, I'll draw the picture and say, since it's 95% confidence, we want to cover 95% of the curve, which means we're leaving 5% out. So 5% would be all this red shaded area. That's alpha, and then alpha over 2 is one of them. So just divide the 5% in half, which happens to also be 2.5%. That coincidentally matches the margin of error, but that's just a coincidence. Okay, so we need to know this z right there. That's z sub alpha over 2. And that's what stat disk is good for. So let's see, let's get stat disk going. And let's go to probability distributions. Let's go to the normal distribution. And the cumulative area from the left, 0.025, is already populated. So evaluate that. That's essentially negative 1.96. And after you do this process a few times, like 95% is such a common confidence level that you'll probably get to know this 1.96 pretty well. Okay, so there's the formula we need to crunch for part A. So let's just grab your favorite calculator. And let's say we want 1.96 squared times 0.5 times 0.5, all that divided by 0.025 squared. Let's see, I'll check and make sure that it looks like I typed everything in properly, and I did. So my output is 1,537. Keep in mind we're always going to round up here, even if this was a 0.1. So, and this is a 0.6, even more so. So 1,537. So for part A, we'll get 1,537. For part B, it says the same thing, except now we know a p-hat. We know that 38% prefer the aisle seat. So exact same formula. Confidence level still 95, so that's going to be the same. Margin of error is still going to be 0.025 squared. That's going to be the same. What's different now is that we know our p-hat. 0.38, which makes q-hat. 0.62. Keep in mind those two just have to add up to 1. So essentially the same formula, we just need to make a small modification. So let me change this to 0.38 and change that to 0.62. And now, with a little more information, we can use a little bit smaller sample size of 1,449. Okay, so that's 33. 35 is pretty similar, but let's just run through it quickly. So if you're good now, you can stop the video, of course, but we'll look at 35 as well. So 35 it says determine the percentage of adults, so sample size again. We want to be 90% confident that we're within 5 percentage points. So 5 percentage points, 5%, looks like that. For part A, the first time around, we're going to assume nothing is known, so we'll put the 0.5, the 50-50. It's our default assumption if we don't know otherwise. And this time the confidence level is different. It's not 95% anymore. So same picture. This time we're only covering 90% of the curve, so I'll shade theoretically a slightly smaller bit of the curve. My art skills aren't that good, but now we're covering 90% of the curve, which means we're leaving 10% out. So 10% is alpha, and then one of those two portions that are symmetric would be half of alpha, would be 5%. So again, we're looking for the z that matches that alpha over 2, that half of alpha. So go back to stat disk. This time we want 0.05. And that's like 1.645. Maybe I'll use 3 decimal places. So that's calculator time again. Let's see. Okay, so this time we want 1.645 squared times 0.5 times 0.5 divided by 0.05 squared. Let's see, and that looks like it all typed in properly, so that's 271. For part B, again, same setup. They're just saying we know 85% is the p hat now. So same stuff, 1.645 squared. P hat is now 0.85, which means Q hat would be the other 15%. Still divided by 0.05 squared. So let's modify our previous calculation. And let's see, this was 0.85 and that was 0.15. Now we're looking at 130, and again we have to round up even here. So because 138 people isn't quite enough, so we're going to go to 139 just to make sure. C says thought question here. Given the required sample size is relatively small, could we just survey people at the nearest college? And we are trying to determine the percent of adults. That's our population. I would say that college students would not be a representative sample of all adults. It's possible that college students have a higher familiarity with Twitter than the general population. Or it's even possible they have a lower familiarity. But in general, college students are not representative of the population of adults as a whole. So you'd want to say something like here is not a representative sample. Okay, so hopefully that helps with 33 and 35.